So I posted the answer keys on Friday for the exit slips for both of last week's, so you should have both of last week's. Please go through those and look at your past assignments. Today we're going to look at special right triangles, which are 30, 60, 90, and 45, 45, 90. I do want to do just a little bit of warm up for those people that were having problems last week with some of these trig functions, with the 3 different kinds, the new kind, secant, cosecant, and cotangent. So we're going to do just a little warm up here first. So given triangle ABC, I'm going to make a right triangle. A being the right triangle. So ABC this way. If sine of C, so we're going to use this angle here. Sine is opposite and hypotenuse. What is the tangent of B? So we need to find this piece over here. So we're going to do Pythagorean theorem. So to find Pythagorean theorem on that one, we have 5 squared plus x squared equals 13 squared. So x squared equals 169 minus 25. X squared equals 144, so x is going to equal 12. I'm going to take the square root of that. So now if I want to find the tangent of the tangent of B, this will be 12 over 5. And you do not put these in a calculator. You don't turn them into decimals. You leave them alone. Okay? All right, the next one. Given triangle CUB, U being the right angle. So I'm going to go CUB. If sine of C, so again, starting up here, is 1/2, so opposite hypotenuse, what's the cotangent of B? So I need this piece over here. So I have x squared plus 1 squared equals 2 squared. X squared equals 4 minus 1 because 1 squared. So x squared equals 3. We get square root of 3. So we're going to leave this one as square root of 3. So now cotangent of B. So cotangent, you would have to do opposite. Normally, if we did tangent of B, we would have square root of 3 over 1. But we need to do our adjacent opposite this time. So cotangent of B would be 1 over the square root of 3. And you can leave it like that for now. Okay? We'll do some simplifying in a minute. All right, so we need to find this missing side to be able to find some of these on for this triangle. So our sine, we can actually do our opposite hypotenuse is 24 over 25. Secant goes with cosine, so I need that x. Cotangent needs an adjacent side as well. So now we have to do x squared plus 24 squared equals 25 squared. So we get x squared equals 625 minus 576. So x squared then equals 49. And we get x equals 7. Okay, so then cosine would be 7 over 25, but we want secant. So we want 25 over 7. And cotangent is adjacent and opposite. So I would have 7 over 24. And so for those people who weren't doing those well before, hopefully that is better. Okay, so in this next section, we're going to talk about leaving answers exact. And exact means you cannot put them in your calculator. So these are no calculator. You need to simplify your square roots and you need to use that type of answer. It will have square roots in them. It's okay. Okay? So use Pythagorean theorem to find the missing side. So if this, on number 1, if this is 90 and this is 45, then 180 minus 90 minus 45 gives us 45 or we have a 45, 45, 90 triangle. And remember, in a 45, 45, 90 triangle, back from geometry or integrated, when you have 45 and 45, the sides are the same. So we have 3 squared plus 3 squared equals our hypotenuse squared. So we have 9 plus 9 equals x squared. So we have 18 equals x squared. Take the square root, and we get x equals, now we have to simplify this. Okay, so we have square root of 9, square root of 2, 9 times 2. So we get 3 square roots of 2. So hopefully you remember that a little bit from last year. I think you guys did them a bit. When you have 45, 45, 90, you should start to see a pattern. Okay, so let's look at the next one. So if this is 90, this is 45, then this has to be 45, which means those two are both 4. So we need to find this side. So we have 4 squared plus 4 squared equals x squared. 16 plus 16 equals x squared. 32 equals x squared. Take the square root. And then we have square root of 16 times square root of 2 equals x. So we have 4 square roots of 2. You see it? You see the pattern yet? Okay. Let's do one. Or let's see if we can figure this out. Okay. So in our 45, 45, 90, our angles are the same. Our sides are the same. Whatever those sides happen to be. If you look at our two answers, whatever the side was, with the square root of 2 is what our hypotenuse was. So this is going to be x square root of 2. Every single time in a 45, 45, 90. Okay? So now, let's look at our 30, 60, 90. Okay, so if this side is 60, I just gave the answer. If this side is 90, then 30 and 60 would have to be 90 for 180. Okay, so if we look at the sine of 30 degrees equals 3 over 6, we could test our calculator with this and see that we get sine of 30 degrees equals 1/2 or 0.5. Okay, this is actually how you check your calculator to make sure that you're in the right mode. Okay, but we want to do Pythagorean theorem and figure out these relationships. So we can tell that that's 30 degrees, opposite is 3, hypotenuse is 6, sine of 30 degrees is 1/2. What does that mean? Let's look at our triangle again without all that stuff on there. So across from our 30 is 3, our hypotenuse 6, and we need to find this side. So we have x squared plus 3 squared equals 6 squared. X squared plus 3 squared equals 30, that's 9, equals 36. Minus 9 and 9, x squared equals 27. And if we take the square root of that, we get square root of 9 times square root of 3. So that's 3 square roots of 3. That's our other side. Okay? Let's look at another one. All right. So this time, I have 90. I have 60. So this one up here is my 30. Okay? We do Pythagorean theorem to find this one. We have to take 2 squared plus 2 square roots of 3 squared. I'm using parentheses on these because the second one absolutely needs parentheses. We're going to have to distribute that squared to both. Okay, we really didn't need it on the 2, but just to make it more cohesive, I put it on both. So now 2 squared is 4. Square root of 3 squared. Square and square root cancel each other out. So I have 4 plus 12 equals x squared. So I have 16 equals x squared. If I take the square root, I get 4. So this side is 4. So if you look at those two triangles, what you should see is across from your 30 is some value x. Across from your hypotenuse is 2 times that value x. And across from your 60 is x with a square root of 3 every single time. And that's what got cut off here. So we redraw this. This one is 45. This one is my 90. This is x. So across from my 45 is x. Across from this 45 is x. And on my hypotenuse, I have x square root of 2. On this other triangle, I have 60 degrees. Here's my 90. Here's my 30. My hypotenuse is 2x. Across from my 30 degrees is x. And across from 60 is x square roots of 3. Always. So let's use those and find some of these down here. Okay, so if this is 45 degrees, this one's 45 degrees. When the angles are the same, the sides are the same, so W equals 4. No calculator needed. Across would be 4 square roots of 2. That's the formula. This is your answer. You have to leave these exact. No calculator. So you have to use these formulas in order to do these. Could you use sine, cosine, and tangent? Absolutely. But that's not what we want, and that's not what ACT or SAT wants. They want to see them in the simplified form. Okay, so the next one. If this is 90 here, this is 60, this one's 30. So across from your 30 is your x value. Your hypotenuse is 2x, which would mean that if I divide by 2 now, x equals 5. So this side is x equals 5. It's got to be half. Or this side over here is double my hypotenuse. And then my 30-degree side gives me my front number on my 60 with a square root of 3. Okay, this next one is a little bit more challenging because across from the 60, you're supposed to have a square root. And because you don't have a square root here, you're going to end up with some square roots in other places. Your square root of 3 is actually going to be on the y and the x side when we get done with this. The way that we do this, we're going to set 18 equal to x square roots of 3, because that's what this would be. We look at our formula. We're going to divide by square root of 3, and this is where we're going to have to get back to some simplifying. So we get x. Now, 18 over the square root of 3. You're not allowed to have square root of 3 on bottom. So where I let you do that last week, this week on these you have to simplify. So now I get 18 square roots of 3. Remember, you have to multiply top and bottom by square root of 3. Square root of 3 times square root of 3 is square root of 9, which is really 3. So I can put this at 3. So now I can reduce this, and I get 6 square roots of 3. So across from my 30-degree angle down here, x is 6 square roots of 3. Across from my hypotenuse, I would have to double that. So I have to take 2 times 6 square roots of 3. So that answer would give me 12 square roots of 3. Okay? When you're working backwards, if a side in the formula has a root on it, and you're given an answer that doesn't have the square root, like this one, 60 is supposed to have a square root of 3. When it doesn't have that square root of 3, both your other sides will end up with the square root of 3 on it. Okay, so this is my final answer. This one is working backwards. This is more of a challenge. Had we have to take the real final for this class, we're going to change it up a little bit. But if we had taken the district final exam, this would have been one of those questions. I'm not sure this one's going to make it on there this time, but it's something to work on. It's definitely something that could show up on the ACT or SAT. So please rewatch this. Please look stuff up on Khan Academy about special right triangles. And I will see you guys tomorrow or later at 11 o'clock if you need some extra help on this. Okay? Talk to you later.